Hey math kids, today we're going to talk about polar form, and this is a definition that you'll need to understand things throughout the book. And a complex number z has polar form that looks like that, where that is the modulus and theta is the argument, and therefore we have this. Okay. Another definition the conjugate is defined so we just change the sign on the argument. Okay. So what we need to do, we need to write in polar form 2I, negative 3, and 1 minus I. So if we look at it on an axis like this, I guess let's draw all these. Okay, 2I is just going to be that, and we can see that the rotation is pi halves. And so if we look at 2I, we know the length of that is just going to be 2. And then we know the argument of 2I is pi halves. And so if we look at 2I and we write it in polar form, we take the argument, and then we do cis pi halves. Okay, over here, negative 3 is going to be 1, 2, 3. So we know that that is just going to be 3, the modulus. The argument of 3 is going to be pi. And so when we put it into our formula, negative 3 is going to be 3 cis pi. All right, the last one, we're going to go 1, negative 1. Like that. And that's a 45-degree angle, or pi fourths. And so the modulus is going to be 1 squared plus negative 1 squared, square rooted, 1 plus 1, and so square root of 2 is the modulus. Since we're rotating backwards, we're going to think of the argument as negative pi fourths, and so when we plug this in, we're going to get 1 minus 6 equals the modulus times cis and the argument. Okay. Now it says convert square root of 3 cis 5 pi 6 to Cartesian. So we're going to go the other direction now. Alright. Now, if we look at this, we're going to write what this is in expanded form. So it's going to be cosine of 5 pi 6 plus I sine of 5 pi 6. And so if we figure out what cosine of 5 pi 6 is, we can come to our unit circle. 5 pi 6 is basically like if we think of this like 0 or 6, This is 1.5, this is about 3, this is 4.5. So we want to figure out where that's at, cosine of 5 pi 6. And so if we're estimating pi as being about 3, that's going to be about 5 halves. And 5 halves gives us about 2.5. So we're going to be in this quadrant. So what I'm going to do is I'm going to cancel out this quadrant. So I'm going to say 5 pi 6 minus pi halves. That's going to be 3 over 3. So we have 5 pi 6 minus 3 pi 6. And so that's going to be 2 pi 6 or pi thirds. So pi thirds is the third rotation. So it's right here, which is symmetric with the first rotation, which is our pi 6, which is square root of 3 halves 1 half. When we move it over here, it's going to be negative square root of 3 halves 1 half. All right, we found out what that is. Now, cosine is the x value, so that's going to be negative square root of 3 halves. And then the sine value is 1 half. And then we still have our square root of 3 on the outside. Okay, now if we distribute the square root of 3 to both of these, square root of 3 times square root of 3 is just 3. Square root of 3 times 1 is going to be square root of 3, and then it's still over 2. And so this is our Cartesian form of this polar form complex number. Okay, now we're going to talk about some of the properties of cis. So if we do cis times, so if we have theta times phi, it's going to give us cis of theta plus phi, or phi, I don't know how you pronounce it actually. Okay, if we do division, turns into subtraction. And then if we do basically that's saying it just has a period of 2 pi, so it repeats every, and k is a integer. Okay, so it says use the properties of cis to simplify cis of pi fifths times cis of 3 pi tenths. Okay, so if we're multiplying 2 together, we just add them. So it's going to be cis of pi fifths plus 3 pi tenths. And then if we get common denominators, we end up with cis of 2 pi tenths plus 3 pi tenths. And that's going to be 5 pi tenths, which is pi halves. Okay, now if we take cis pi halves and we write it in expanded form, we're going to get cosine of pi halves plus I sine of pi halves. And if we think of our unit circle, pi halves is right there, which is going to be 0, 1. And cosine is our x value. Sine is our y value. And so overall, 0 plus I times 1 is just going to be I. So this actually just simplifies down to I. Okay, the next one is a division. So cis pi fifths, cis 7 pi tenths. So remember, division gives us subtraction. So that's going to be cis of pi fifths minus 7 pi tenths. Common denominators, 2, 2. So we get cis of 2 pi tenths minus 7 pi tenths. So that's going to be cis of negative 5 pi tenths, which is cis of negative pi halves. If we expand that down here, we're going to get cosine of negative pi halves plus I sine of negative pi halves. So if we draw a unit circle, negative pi halves is right here, and that's going to be 0, negative 1. X value goes to 0, and then I times negative 1. So overall, we get negative I. So this is just negative I. Okay. Okay, so we're asked to simplify this. So one way we could envision this, we could change this into just this part. We could change this part into a mixed number, 17 and 5/6 pi, which we could envision that as 18 pi minus pi 6. And so if we look at the original, we could rewrite it as 18 pi minus pi 6, like this. And we could write this as we had the property that said cis of pi plus k2 pi equals cis theta, like this. And so this is like our k2 pi, because that would be like 9 times 2 pi. And so we're just going to be left with cis of negative pi 6. And then if we expand that, we get cosine of negative pi 6 plus I sine of negative pi 6. We go to our unit circle. We rotate negative pi 6, which goes here, which is symmetric with this, which is square root of 3 halves, 1/2. But down here, it's square root of 3 halves, negative 1/2. Cosine value plus I times the sine value. So it's square root of 3 halves minus 1/2 I. Alright, it says use the properties of cis theta to find the transformation which moves z to iz. Okay, so what we're going to do is we're going to write something in polar form like that, and then we know that I is going to be 1 cis pi halves. Okay, let me just explain that. So if we're purely imaginary, we're right there, and we know that the length of that is 1, so that's where the 1 comes from. We know the rotation is positive pi halves, so that's where all that came from. And so iz is going to be equal to these multiplied together. So if we take this, it's just cis pi halves multiplied by r cis theta. And knowing the properties are, if we multiply these together, we multiply the outsides, which are just r times 1 is r. And then if we multiply the insides, it's cis of pi halves plus theta. Okay, and all that's saying is that we have to rotate in the positive direction, which is counterclockwise by pi halves to get that. And if you remember on a previous video, we proved that a different way, and that was the same conclusion that we came to, that z to iz is a rotation counterclockwise by pi halves. Okay. Now, if a complex number z is multiplied by r cis theta, then its modulus is multiplied by r, and its argument is increased by theta. Okay, so we're going to use that on this next one. So z is equal to 1 plus square root of 3i. We want to write that in polar form. So we're going to look at it on a graph first. So we go over 1, and we go up square root of 3. We get this point. And to write it in polar form, we need to find the modulus. So we do 1 squared plus square root of 3 squared square rooted, which gives us 1 plus 3, which gives us 4, which gives us 2. Okay, so z, modulus of z is 2. And then to find the argument, we just need to do, so we think of this like this is 1, this is square root of 3, this would be a right angle, and we want this angle right here, so it's going to be a tangent. So tangent theta equals the opposite over adjacent. If we simplify that, tangent theta is equal to square root of 3. And then if we look at that on this, or let's see, should I just plug it in to a calculator? We want to know where we have square root of 3. So if we do it like this, this is going to be square root of 3 halves 1 half, and then this is 1 half square root of 3 halves. Now, since tangent is y over x, which one's going to leave us with this? Well, we want this on top, and 2's will cancel, we're left with square root of 3. So this is where we're at, and that rotation is pi thirds, and so that's what our argument is. So arg z is equal to pi thirds. Okay, now we have the argument, we have the modulus, so we can write it in polar form. And so polar form is going to be z is equal to 2 times cis pi thirds. And I think that's everything on part A. Now part B says, hence multiply z by 2 cis pi 6. Okay, so now we want to do 2 cis pi thirds and multiply it by 2 cis pi 6. So when we do that, we're just going to multiply the outsides, so we get 4, and then we're just going to add the insides. Okay, we need to multiply this by 2, so 2 pi 6 plus pi 6, 3 pi 6, and so that's pi halves, so 4 cis pi halves. Okay, and then we want to take that, whoops, don't have any room, and we want to expand it. maybe I can go this way. Okay, so I'm going to expand this. I'm going to say 4 times cosine pi halves plus I sine pi halves. If we look at this, pi halves is right here. This is 0, 1. So we get 4 times cosine goes to 0, sine goes to 1. So we end up with 4i when we simplify that. Okay, part C, illustrate what has happened on an Argand diagram. All right. So when we started with the first one, or actually, don't I have it already over here? Yeah. So here's our original, this blue one right here. Because it became 4i is just like up here, we'll say. Here's 4. We rotated, so we already knew that this was pi thirds. And the remaining piece right here is pi sixth. So we rotated pi 6 more to become completely vertical. And then we just, let's see, our length right here, remember, originally was 2. And so we just increased by, we multiplied by 2, and now our length is 4. Okay, and the last part on this one, what transformations have taken place when multiplying z by 2 cis and pi sixth? So we dilated by a factor of 2, and then we rotated counterclockwise by pi sixth.